Hello, welcome to this video. This video is for IXL 8.W.7, solve one-step equations. Its three-character code is 5 Juliet 4. So we've done one-step equations with addition and subtraction, and then we did one-step equations with multiplication and division, and now we're going to be just doing one-step equations. This means that we are going to find multiplication and division and also addition and subtraction in our problems today for this activity. The key thing to remember is that addition and subtraction are inverse operations and they undo each other, and likewise multiplication and division are inverse operations and they undo each other as well. Just a little bit of a disclaimer: whenever I'm working the problems, I always use the term opposite operation as opposed to inverse operations. So let's go ahead and get started. The first problem is 2n equals 2. Well, remember that the object of solving an equation is to isolate the variable, and isolate means to get it all by itself on one side. So let's go ahead and I'm going to rewrite today. 2n equals 2, so the 2 is tied to the n through multiplication. The opposite operation of multiplication is division. Remember, every fraction is a division problem. And we're going to divide by the very number we wish to get rid of, which is 2. And what we do to one side, we have to do to the other side as well. The 2's are going to cancel each other, leaving us with just n, and 2 over 2 equals 1. Now, you probably could have solved this without all that, just asking yourself what number times 2 equals 2, and realize that it's 1. But still wanted to show the process, so we're good to go there. H plus 10 equals 13. So the h is tied to the 10, and let's go ahead and rewrite, I suppose. H plus 10 equals 13. So the 10 is tied to the h through addition. The opposite operation is subtraction. We're going to subtract the very number we wish to get rid of, which is 10. And what we do to one side, we have to do to the other side. So the positive 10, negative 10 are going to cancel each other and leaves us with just h on the left. And 13 minus 10 is 3, so we end up with h equals 3. And remember, you could always plug your answer back in, substitute the answer back in, and evaluate the equation then. And so if you plug the 3 in for h and then think, okay, 3 plus 10, is that 13? Indeed it is. I must have gotten the answer correct. So you can always go back and check your answers by plugging in your solution. So I have negative 12 equals negative 2t. And so it looks like we're dealing with some negative numbers, so we're probably going to have some of that addition and subtraction of negative integers, addition and subtraction of integers, which could be negative and positive numbers. And also we'll probably have some multiplication of positive and negative numbers. And so we need to know those rules. And of course those rules are that if the signs are the same, positive plus positive times positive is positive, negative times negative is positive. So if they're the same sign, the answer is positive. If they're different signs, such as negative times positive or positive times negative, then the answer is going to be negative. A little bit of review there, right? First day, new tongue. Still trying to get used to it. So the negative 2 is tied to the t through multiplication. The opposite operation is division. I'm going to divide by the very number I wish to get rid of, which is a negative 2. And what I do to one side, I have to do to the other. The negative 2's are going to cancel each other, leaving me with just t. And negative 12 divided by negative 2, well, that's negative divided by negative, so it's positive. 12 divided by 2 is 6, so t equals 6. Here we have p over 4 equals negative 4. So the p is tied to the 4 through division. The opposite operation is multiplication. We're going to multiply by the very number we wish to get rid of, which is 4. And what we do to one side, we have to do to the other. So the 4 is going to cancel each other, and that leaves us with just p on the left. And negative times positive is going to be a negative, and 4 times 4 is 16. If you're wondering how these cancel, go back and check out the videos, the video for solving one-step equations using multiplication and division. You kind of get an idea. There I explain why those 4's are canceling each other. Here we have negative 9 equals t minus 63. So here we have the t is related to the 63 through subtraction. This is like a negative 63 here, right? It's like plus a negative. But the opposite operation of subtraction is addition. And we're going to add the very value we wish to get rid of, which is 63. And what we do to one side, we have to do to the other. So we're left with the 63s canceling each other, leaving us with just t. And now we have negative 9 plus 63. So think of that negative 9 plus 63. We realize that we are adding and subtracting a negative and a positive number. So that means we're actually going to subtract the values. So 63 minus 9. And 63 minus 10 would be 53, so this must be 54, right? And so we put our 54 here, and the 63 has a greater absolute value than the negative 9, so the 63 is going to win out, so 63 is positive, so 54 is positive. So we end up with 54. On the next one, we have n minus negative 19 equals 68. Well, if you know anything about me, I do not like minus a minus, so I'm going to change the sign here to addition. Take the opposite of the following number, which is negative 19, so the opposite is positive 19, and bring down our 68. Next, we realize that the n is related to the 19 through addition. The opposite operation is subtraction. We're going to subtract the very value we wish to get rid of, and what we do to one side, we're going to do to the other. The 19s are going to cancel each other out, leaving us with just the n on the left. And 68 minus 19. Well, 68 minus 20 would be 48, right? But we only need to take off 19, not 20, so we're going to add 1 back to that 48 and get 49. We could always double check. 9 plus 9 is 18. We carry the 1. 4 plus 1 plus the 1 we carried is 6, so we'd be back to 68. So indeed it is 49. And we could always double check our answer by plugging that 49 in there and see if that works out. Here we have 24c equals 864. And the c is related to the 24 through multiplication. The opposite operation is division. Every fraction is a division problem. And we're going to divide by the very number we wish to get rid of, which is 24. And what we do to one side, we need to do to the other. So the 24 is going to cancel each other, leaving us with just c on the left. And then we have 864 divided by 24. So 864, probably could just use a calculator, probably be a little bit easier. But 24, let me see, it'll go into 75 3 times. And 4 times is going to be too much, so let's go with 3. 3 times 4 is 12. Carry the 1. 3 times 2 is 6. And add the 1, that's 7. 6 minus 2 is 6 minus 2 is 4. 8 minus 1, or 7 minus 8 minus 7 is 1. My brain's already thinking of the answer. I'm already thinking ahead, thinking about bringing the 4 down. So 24 into 144. Now I know that 12 times 12 is 24, right? And so if 12 by 12 is 144, and I'm needing 24, well, 12 times 2 and 12 is 6. So this means that, see, this is all still equals 144, right? Because 2 times 6 is 12. Now 12 times 2 is 24. So that means 24 times 6 is 144. So therefore, 24 must go into 144 6 times. So a little bit of mental math. I was already thinking all that inside my head, and I thought, how can I show that? But that's how I mentally get to that. So we end up with 36. So if you're kind of recognize things and you can kind of break this down this way and understand this thought process right here, it's really helpful for mental math, really help develop your mental math skills. All right, so we have j plus negative 0.5 equals negative 10.77, good old decimals. So the negative 0.5 is related to the j through addition. And actually, this is one of those times where I like to think of it as that this is just a negative 0.5. So I need a positive 0.5. So a positive is like plus, right? And when I do to one side, I'm going to do the other. So I'm actually adding, because this plus and negative can get confusing. So let's just realize that this is a negative value, and we need to add a positive value. It's opposite, right? So I'm adding 0.5 here. Now these are going to cancel each other out, leaving me with just j. And now these are pretty much lined up for me already, right? Let's throw a 0 on so we can see that there. 7 plus 0 is 7. 7 plus 5 is 12. Carry the 1. This is where our decimal goes. And 1 plus, well, we can just do the 1 plus 10 here and get the 11. And, oh, that's a negative. Mr. T, you're wrong. Can't do that. This is a negative 10, right? So what we have to do here is, let's look at it this way. Negative 10. Now, if I type that in the calculator, it would be just fine. But let's do this here. Negative 1077. And we're going to add 0.5. So we are adding a negative and a positive value, correct? So we're actually going to have to do subtraction. So we would want 10.77 minus the 0.5. So we're going to subtract. Now 7 minus 5, or 7 minus 0 is 0, or 7. My brain's already thinking the next column over here. I'm getting ahead of myself today. 7 minus 5 is 2. And let's go ahead and just bring down the 10. So now we found the difference between them because we're adding a positive and negative value. So we end up with 10.27. However, the negative 10.77 has a greater absolute value than the 0.5, the positive 0.5. So since the one with the greater absolute value is negative, our answer is going to be negative. So we end up at negative 10.27. Hope I didn't lose you there on that one. Brain's not working too well today. All right, so we have b minus 11 equals negative 3.2. These decimals are going to show up in like the 80s and 90s. So you won't have to deal with them until you get to those higher scores on the activity. So the b is related to the 11 through subtraction. The opposite operation is addition. And we're going to add the value we actually wish to get rid of. So what I'm thinking in my head is I think of this as b plus negative 11. So I need to add the opposite to get rid of it, right? So we're basically just putting together some opposites to create 0. So that's the idea there. And so since we're adding 11, we're going to add 11 over here as well. And on the left, the 11s cancel each other, leaving us with b. Now we have negative 3.2 plus 11. So that's negative 3.2 plus 11. So we're adding a negative and positive number together. That means we actually have to subtract. So I'm going to need a decimal because I got to line those decimals up. Now 0 minus 0 is 0. We're going to have to borrow, right? This is going to become 0 here. And 10 minus 2 is 8. Put our decimal there because we keep our decimals lined up. Now I can't take it away, but I can't take 3 from 0, but I do see that this is a 1 here already, so I just think 10 minus 3 is 7. So I end up with 7.8. I drop that 0 off the end. Doesn't change the value. And the 11 has the greater absolute value, so it's positive, so my answer is going to be positive. So I end up with 7.8. And also, you know it's positive because if you were on a number line down here, it would be negative 3.2 someplace. So this means here's 0. That means we're going to go back that way 11 spaces. So you know your answer is going to be down here. It's going to be in the positive area. So you know that 7.8 is positive. On the next one, we have d plus 1 equals 7.2. So it's related by addition. So let's use subtraction. Let's subtract the 1. That's what we're trying to get rid of. And what we do to one side, we have to do to the other. I'm going to put a decimal here so that lines up there. We can see that when we get to it. The 1s will cancel each other, leaving us with just d. And 7.2 minus 1, well, that's going to be 6.2, right? Don't really have to do it off to the side there. Let me kind of mentally do that one pretty easily. The last two problems are, here we go with 4.23 equals 3c. The 3 is tied to the c through multiplication. The opposite operation is division. And we're going to divide by the very number we wish to get rid of, which is 3. And what we do to one side, we have to do to the other. The 3 is going to cancel each other, leaving us with just c on the right. Now we need to do the 4.23, and we need to divide it by 3. So 3 are going to 4 once. Do the subtraction there, and line up, keep our decimal where decimal goes. And bring down the 2. Oh, there we go. That'll work well. 3 goes into 12 4 times. And 3 times 4 is indeed 12. So we get 0. Let's bring down the 3. And 3 will go into 3 once. So we end up with 1.41. Last problem. The j is related to the 21 through division. The opposite operation is multiplication. We're going to multiply by the very number we wish to get rid of, which is 24. And what we do to one side, we have to do to the other. I'm just happy it's not decimals. I'm still going to have to do this multiplication of 24 by 24, but that's fine. And silly me, I am looking I'm thinking, oh good, no decimals, and I write the wrong number. The number we wish to get rid of is 21. So if, hopefully you caught that. If you were sitting there thinking 24, why 24? So good job if you were thinking that. It caught me. The 21s cancel each other, leaving me with just j on the left. And now I need to do 24 by 21, so 24 times 21, and, well, that's going to be 4, and that's going to be 2, right? Put a place holding 0 there. 2 times 4 is 8. 2 times 2 is 4. Now we got to add these together, right? So we get 4, 0 for 10, carry the 1, 5, 504. So j equals 504. All right, so those are all of my examples for IXL 8.W.7 solve one-step equations. Remember, just use those inverse operations to undo whatever the relationship is that the values have with the variables. Good luck in your activity.